So what we are going to discuss? We are going to discuss the energy stored in a capacitor. Okay. So we are talking about parallel plate capacitor. So we have two plates. Suppose one plate is this. This is positively charged plate. Suppose the another one is negatively charged plate. Okay. This is plate one. This is plate two. It having the charge total charge. Suppose that is plus Q, and it is having the charge total charge minus Q. So now from where the energy will come? So first of all, we know that this is a two plate. So if we send some amount of charge from plate 2 to plate 1 or plate 1 to plate 2, so we need to do some work. Again, I am repeating. If I want to send some charge from this, suppose from plate 2 to plate 1, I just want to transfer a charge of dq from plate 2 to plate 1. Okay, so the work done in moving a charge from plate 2 to plate 1 will stored as electric potential energy. So you can write the work done the work done in moving moving a charge from plate 2 to plate 1. The work done in moving a charge from plate 2 to plate 1 will stored as electric potential energy. Sometimes it may be come in the question how the energy will store in a capacitor. So you need to know that whenever we want to transfer some charge from plate 2 to plate 1, so we need to do some work, and that work done will be stored as electrostatic potential energy, or generally energy that is stored in a capacitor. So you need to know the work done in moving a charge from plate 2 to plate 1 will stored as electric potential energy. Okay. So now let's find out what is the work done and what is the formula for the energy. So first of all, what we need to do, this is a parallel plate capacitor. So it has some potential also, okay, and having some capacitance also. So generally if you see what is the formula of capacitance is C is equals to Q upon V. C is the total capacitance of the plate, Q is the charge, and V is the potential. So from here, if you find out the value of V, so the value will come Q upon C. Now, first what we will do, we will send a very small amount of charge from plate 2 to plate 1. What we are going to do, we will send a very small amount of charge dq from plate 2 to plate 1. So in that process, some work done will be there. Okay, now after that we'll send the complete charge from here to here. That net work done will sending the whole charge from one plate to another plate will stored as electric potential energy. So first of all, the small work done in moving a small charge dq, moving a small charge dq from plate 2 to plate 1. So the work done, the formula of work done is W is equals to, generally the formula of potential is V equals to W upon Q. What is the formula generally for formula of potential? V is equals to W upon Q. Now if you want to find out the work done, it will Q into V. So which charge we are sending? A very small charge. So it may be like V into dq. This is equation 1. Whenever we are sending a very small charge dq from plate 2 to plate 1, what will happen? The small work done will be there, and that work done, small work done you can write. So you can write it as dw. Now, so the net work done. So the net work done in moving a charge capital Q The huge amount of charge now we are sending from plate 2 to plate 1, large amount of charge. So the net work done in moving a charge capital Q from plate 2 to plate 1 will be given as W is equals to integration of TW. And what limit will put? Initially, the charge is 0. Whenever we are not transferring any charge, after transferring, we are transferring a charge of capital Q. So that net work done will be given as the integration, and the limit will start from 0 to capital Q into dW. So this is how we can find out the net work done. So basically अब dw क्या है हमारे पास एक बहुत स्मॉल अमाउंट ऑफ वर्क है ओके अब उसकी हेल्प से हम ज्यादा अमाउंट ऑफ वर्क निकालना चाहते हैं तो जितना भी हम चार्ज वहां पे ट्रांसफर कर रहे हैं तो वी विल इंटीग्रेट इट पुटिंग दैट लिमिट सो द लिमिट इज फ्रॉम 0 टू q so dw will be given as 0 to q into dw note it down everyone. So I hope you have noted down everything. What we are doing, we are just sending a very small amount of charge from plate 2 to plate 1. Then we are sending a large amount of charge. So the net work done in moving the large amount of charge from 2 to 1 will be stored as ln. So now if you put the value, so W integration from 0 to Q, it is V into dq. V into dq. Now, what is the value of V? The value of V is, what is the value of V? Q upon C into dq. Now, 1 upon C will be common. Integration of 0 to limit 0 to Q, Q into dq. So, the integration of Q upon dq means it is given by integration of Q की power 1 into dq. So, Q की power 1 means the integration is 1, Q की power 1 plus 1 upon 1 plus 1. It will be Q की power 2 upon 2. So, the integration of this will be 1 upon C is common. Inside it will be Q square upon 2. Or if you put the limit, it will become half C into Q square. So, finally, this work done will store as energy. This work done will stored as electric potential energy, and it is given by U is equals to half Q square upon C. This is the formula of energy. Capital Q is the charge we are transferring from plate 2 to plate 1. C is the capacitance of the plate. So the energy is the formula for the energy stored in a capacitor is given by U is equals to half Q square upon C. Again I am repeating, the work done in moving a charge capital Q from plate 2 to plate 1 will stored as electric potential energy, and its formula is given by U is equals to 1 upon 2 or half Q square upon C. So this is a general formula for the energy stored in a capacitor. Now what else we can do? We can write this formula in the different forms. So the general formula is U equals to half Q square upon C. In board examination it may be asked in 2 marks. Okay. And also very important for your competitive examination. Now how in other form we can write it? Let's see. So it is given by half Q square upon C, and we know that Q is equals to C into V. If we put the value over here, so U will be become half C square V square upon C. C get cancelled, and it will become half CV square. So this is another formula of potential energy or generally energy stored in a capacitor. The first formula, this is the first formula. This one is the first one. This is the second one. One is U equals to half Q square upon C. The another one is U equals to half CV square. Or generally what we can write? Now, if you find out the value of V, From here it will be Q upon C. So if this formula can be written as half Q into Q upon C. So Q upon C will become V. So the formula will become half Q into V. So this is the third formula of the energy store. So we have generally three formula for the energy stored in a capacitor. The first formula is half Q square upon C. The second formula is half CV square. And the third formula is half Q into V. So this is the formula in the terms of charge and capacitance. This is the formula in the terms of charge and potential. And this is the formula of charge and potential. So these are the formulas for the energy stored in a parallel plate capacitor. Please note it down. Now in this there is another very important thing that is given, may be asked, that energy density of an electric field. Plate is there, so if the plate is there, so there is some electric field is also there. So another thing that we need to know, the energy density of an electric field. The energy stored due to an electric field also. So you can write the energy density of an electric field, the energy density of an electric field. So basically energy density can be given as energy per unit volume, So here small u can be denoted by the energy density, capital U upon V. Now if we are talking about a parallel plate capacitor, this is a parallel plate capacitor, the separation is D, area of the plate is A, electric field between the plate is E. So if we talk about the volume of this plate, will be, volume is area into separation, and whereas the formula of energy is half Q square upon C. So what we can write this, U is equals to half Q square upon C upon V. Now we will put the value, it will become half Q square upon C into 1 upon V. Now put all the values, and also we know that for a parallel plate capacitor, the capacitance is given by epsilon naught A upon D, and the charge is given by sigma into A, and for the charge is given by sigma into A, and also the electric field, or generally you can say the electric field between the plate is given by sigma upon 2 epsilon naught. Okay, so from here, okay, inside the plate it is sigma upon epsilon naught. So from here you can find out the value of sigma, it is E into epsilon naught. So if you put all the values, and Q is equals to sigma into A. So this is one formula, this is the second formula, and this is the third formula, and this one is the fourth formula. We will apply all the formula, that volume is equals to area into separation, capacitance of a parallel plate capacitor is epsilon naught A upon D, electric field inside the parallel plate is sigma upon epsilon naught. From here the surface charge density is E into epsilon naught, and also charge of that plate will be Q equals to sigma into A. If we put all the value over here, the energy density will be, half will remain the same. Instead of Q square we can write sigma square A square. Instead of C we can write epsilon naught A upon D. Okay, and instead of V we can write A into D. So dd will cancel over here, this A and this A will cancel from this. So this formula will become something like half sigma square upon epsilon naught. Energy density, you can see here, if you put the value of Q square, C and V, all the values will put. This D will cancel. This A square, A into A will become A square. A into A will cancel out this square. So only here sigma square upon epsilon naught will be there. And what is the value of sigma? The value of sigma is epsilon s naught into E. You can also write it epsilon s naught into E. So we will put the value. The formula will be half epsilon s naught square E square upon epsilon s naught. Epsilon s naught one get cancelled. So it will become half epsilon s naught into E square. So the formula for the energy density of an electric field, the formula for the energy density of an electric field is given by half epsilon s naught into E square. This is the formula of energy density of an electric field. This is the formula where epsilon naught is the permittivity of the free space and E is the electric field between the plates. So the energy density from this formula is given by U equals to half epsilon naught E square. One of the very important formula till now. These two will come together sometime. The question is to find out the potential energy find out the energy stored in a capacitor, and in second part find out the energy density of an electric field. So this is how you can find out the energy density. Okay, please note it down, everyone.